welcome to episode 4 of Battleships. In the previous episode, we started writing our battleship class that represents battleships, obviously. And we also made a function to render a board that displays where these battleships are. In this episode, we're going to figure out how to combine our battleships with the shots that our user is taking. We're going to figure out how to combine them to represent an entire game state, and how to tell our user when their shots were hits and when they were misses. The order of business: first, decide how to represent the overall state of the game. Once we've done that, we want to figure out how to work out whether a shot was a hit or a miss. Let's open up our Scratch file. We want to figure out how to represent the overall state of the game, as we just said. And I would like to wrap everything needed to understand the game position in a single class. And this is this idea of single responsibility, or separating out each piece of functionality of your class, your program, into discrete different pieces. So, for example, so far we have this class just responsible for knowing where battleships are. This function just responsible for rendering the position of a board. Let's call it our game board class. We could also possibly call it the game state. I'm not sure. But that's all it does. It just contains all the information needed to understand a game position. So what is that information? Well, it's the battleship locations. It's the shot locations. And it's also the board dimensions, the width and the height. And then we've got an interesting thing to figure out, because there's also the battleship health, and was a shot a hit or a miss. And these are arguably sort of part of the game state, but they're also derived properties, you could call them, where they come from the battleship locations and the shot locations. They don't sort of have any independent existence outside of that. So let's start. I'm not sure exactly where we're going yet, but let's start with this game board class. And we'll give it an initializer, and we'll say, this is interesting as well, because what does it mean to have an empty board? Does it mean we're certainly going to want a board width and a board height. We know that much. So let's just store them. But what else does it mean to have an empty board? Does it mean is an empty board a board with no shots taken, a board with no battleships placed on it yet? What does it mean? And we get to decide that. There's no right answer separate from what we decide to do. I think it should include battleships. I think that we should just say that in order to initialize a board, you have to know where the battleships are going to be. And I think that because the battleships are fixed. The battleship placement is something that happens once right at the start of the game, and then they're fixed forever. I think if battleships were something that were placed repeatedly, or not placed at the very first stage of the game, then we might want to initialize the board without any battleships and then add the battleships in later. But because they're added once at the start, I think it makes sense just to say a game board is not a game board unless it has any battleships on it. For shots, I think for now, let's just initialize shots. We'll say, so a board has shots, but when it's initialized, it doesn't have any yet. So shots is just an empty list. We could, if we wanted, pass in a list of shots, and then we'd have to think about, well, why might you want to do that? And the only time I can think of is if we did want to do something where we could save games and then reload them later. So you might initialize a board that already has had some shots taken on it. However, we're not anywhere near writing any functionality like that, and if we did want to add it, we could easily change the initializer for game board to include a shots parameter. So for now, let's just initialize battleships to be battleships and shots to be an empty list. And so this is what a game board is going to look like. This is all of the stuff that we need in order to represent a game of battleships. Now we come on to these properties here. Like, how should we note when a battleship has been hit somewhere, and how should we note when a shot was a hit or a miss? As I mentioned, we could just not do it, and just every time we need to know whether a battleship has been hit, just on the fly go back, look at all the shots that have been taken, and just return the result on the fly. And there's something quite intellectually pleasing about that. We have each piece of information is just stored once, and then everything else is calculated from that. However, I think it's going to be more pragmatic for us to calculate when a shot is taken, whether it updates a battleship's health, and also store on the shot itself whether it was a hit or a miss. So I think let's add a take shot method to the game board, and we'll say that a game board knows how to update itself when a shot is taken. You could argue that that's not something a game board should be responsible for. A game board is just a dumb container class that just all it does is keep track of these four things, and maybe this game logic, this sort of way that the game actually changes and evolves, should be delegated into a different class or a different method. And I do have some sympathy for that thought. But I think our game at the moment is sufficiently simple that splitting out this functionality into loads of different loads and loads of different classes is probably just going to cause more complexity than we need. It won't actually solve any problems. It may be that if more rules got added to the game and the game board got more and more complicated and responsible for more and more stuff, that we might want to separate out this functionality into some other part of our code. But for now, let's just say that game boards know how to update themselves. So as we said, we're going to want to update Battleship with any hits that it's taken, and then also we're going to want to save the fact that the shot was a hit or a miss. We're going to need to maybe deepen our idea of what it means to be a battleship, or what it means to be a shot. So remember last time we talked about how if all a battleship had was a body, maybe we wouldn't bother wrapping it in a class. But we're saying now that battleships also have a notion of whether they've been hit or not. And there's loads and loads of ways we could store this information, all of which would work and be valid. We could, for example, instead of having the body be just a list of coordinates, we could have a further class called a battleship component or battleship square or something, which would have a location, so a single coordinate, and a health, or maybe is hit, which would be true or false. And then a battleship where it might have however many squares it takes up, it would have one of these battleship square classes for each one, and that would represent the location of that square and whether that square had been hit. I think that's, again, getting too complicated. We don't need to add all these different classes that you need to understand in order to understand how the code works. I think a decent way of doing it would be just having an array, a list of hits, which starts as false, 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 or however many elements there are in the body, and then say the third element, or I suppose the second, if you're numbering from 0, if that gets hit, we change this that corresponding element to be true in order to indicate that it's been hit. But we initialize it with just an array, a list of falses that is as long as our body. So this will give us, just to show how the syntax works, say length of the body is 4, that will give us this. And we have a similar situation to we were talking about before, where we with the board, where you could imagine passing in hits if there was any way that the battleship could have already been hit in the course of the game, if we were reloading a saved game or something like that. However, again, no reason that we would want to do that yet, so we'll just force self.hits to start as this list of falses. So that will allow us to update our battleship with any hits. But if we want to save the fact that a shot was a hit or a miss, again, lots of ways we could do it. The most consistent with what we've done so far is just to make a shot class. It's going to be extremely simple. You could argue that it's so simple that it shouldn't be a class, maybe it should just be a dictionary or a little tuple, but it's just going to have a location and whether it was a hit or not. And that's it. It does not need to do anything else. As I said, extremely simple. It just means that we are able to tie the location of the shot and whether or not it was a hit together. And that will allow us to calculate and store this fact, whether a shot was a hit or a miss. With all of that said, let's actually do what we set out to do. When someone takes a shot, the important thing is to figure out whether it was a hit, and if it was a hit, update the corresponding battleship. And the way we can do that is by iterating through the battleships on the game board. And if any of them were hit, then, well, the shot was a hit. And if none of them were hit, then the shot was a miss. And so we can say if the shot location is in the battleship's body, it was a hit. So if it was a hit, what do we need to do? We need to record that fact. So we'll start with this is hit variable that starts off as false by default, but if the shot was a hit, then it becomes true. And not only that, but we will want to update the battleship to, well, we need to know, we don't need to know whether the battleship was hit, which is what we're finding out here. We need to know which element of the battleship was hit, which index. Was it because if it was the first element of the body, we want to update the first element of is hit to be true. If it's the last, we want to update the last element to be true. So there's a way to do this. Let's see if I can remember it. I think it's the following. Brilliant. If you have a list and you call the .index method, it will tell you the index of the item that you pass in here. So in this case, 5, it's at index 1, because obviously the first element has the index 0. And if we did, for example, 7, 8, 9, 0, 1, 2, 3, if we did .index 1, that will give us back 4. One complication we'll have to figure out is if we do index 10, it actually throws an exception, which is kind of annoying. I would personally, I know this isn't how Python likes to do these things, but I personally prefer if it returned none, just to indicate that it wasn't there. But it throws a value error, we'll just have to catch it and deal with that. So the index, as we've said, is b.body.index shot location. And as we know, if this will, in the case that the shot location is in the body, this will give us back the index of it. However, if it is not, it will throw an error, in particular a value error. So we just need to catch it if that happens, like so. And accept value error, don't do anything, just keep going. So if, oh, we need to change this, if index is, oh no, in fact we don't need an if statement anymore, because if this is an error, it will immediately jump to this except. You could argue, we could wrap this up in a little helper method on the battleship. Why not? Let's make the battleship class pull its weight. And so by a helper method, I mean we just ask the battleship itself, is this, here's the location, tell me the index of the index that is in your body. So we just do exactly the same approach. It's not a shot location anymore, it's just location. And then we can catch that value error that we were catching before and return none. It's important, we could have just caught exception like that, just to catch any exception, but it's important not to do that, because then say if we'd typoed that like that, this accept exception would, I believe, catch that exception as well. Whereas we only want to catch the very specific value error that might be returned by our body. So now we can do body index, shot location, then the code out here becomes a bit simpler. So you say if index is not none, then that means it was a hit. That means we should update the battleship in question, and we can also break out of this loop, because we know the shot was a hit, we know which battleship it hit, our job's done, we don't need to do anything else. So we've updated the battleship, that's done, and now we need to add on a shot. And so we create a shot object, and in order to create a shot object, you pass in its location and whether or not it was a hit. And we know both of those things already. I think that will do it, actually. Let's test it out. We'll hard code in some examples. Let's get rid of all of, well, no, we'll just add on to this. We can render battleships, sure, why not? Oh, no, we need to build. So we've got our battleships. We need to initialize a game board. And as we saw, in order to do that, you pass in battleships, a width, and a height. So we'll go battleships, a width, and a height. And then let's take some shots. Let's shoot at 1, 1, because we know that will be a hit. 0, 0, because we know that won't. And then 5, 7, because that will be a hit as well. And then we can iterate through each shot and then take a shot at the corresponding position. Let's just see if that even runs. Let's see if it runs. Nope, that's not entirely surprising. List, I've done the same thing again. So line 59, I tried to call body as a method, but it's not, it's just a property. Well, it didn't error. Now let's see if it actually worked. Let's print gameboard dot shots, and then actually, okay, something we'll work on next time perhaps is, instead of printing out this impenetrable just description of what a shot or a battleship is, we'll have it print out some actually nice properties. But for now, no time for that. We can just print out the information manually, and then same thing for battleships. And we're hoping that these will show the updates that we will have made from taking all of these shots. I think it was called hits, wasn't it? Well, something happened. Okay, this is interesting. Let's tidy up our debugs, shall we? Oops. Let's print a nice little line after that, and another line here. So now when we do this, well, obviously we get an error because what happened there? 59. Oh, that should be self.body. That was just a mistake from copying it over. Okay, that looks good to me. So we thought this would be a hit, we thought that would be a miss, we thought this would be a hit, and the true false true show that we got that right. And then this was hit, and then this was hit in the 5-7 spot, and then this was not hit at all. That looks like it's working pretty great, if you ask me. I think that might be it for this episode. Let's see. Yep, we know whether a shot was a hit or a miss, and we decided how to represent the overall state of the game. Right, what's coming next? Next, I think, we're coming to the point where we might be almost done with our one-player version of this game, which is nice, because then we can join it in to make a two-player version and play some actual real battleships. Let's figure out how to make, next time, we'll figure out how to make a render function that we can actually show to our player, because we don't want to show them this, because that makes it too easy, doesn't it? If they can see the battleships, and we don't want to just show them the shots either, because then is that expected? Let's just gameboard.shots. I find that a little surprising. Should I? We'll come back to this. We'll make sure, oh no, it's not surprising. But we want to make a nice render method that we can show to our player that shows them just their shots, it shows them whether their shots were successful, and also tells them when they've won as well. So that's next time. I will see you then.